Okay, so today I'm going to be demoing for lab 1. First thing I'm going to show you is the two input logic gates for NAND, NOR, XOR, and XNOR. So I have them right here. Let me just set these all to 0 for now. So for a NAND gate, um, when they're both 0, it's gonna be 1. And I have the following truth tables here to show for what each output would be. So for example, an XOR, so let's see if they're both 1, it should be 0. So that is what we get here. For an XNOR, let's say 1, 0, we should get 0. So we'll do 1, 0, we get a 0. And if we do 1, 1, it lights up. And this is the only one that lights up when it's both 1, 1 out of these sets. But yeah, there's not much else to show here other than just looking at the truth tables, any configuration you do. So for example, on NOR, if they're both 0, you get 1. Okay, for this next part, I'm going to demo the parent mux sheet. So let's go to the multi-sim table. So this is the mux sheet that we're given. Just to show you the subsheet here, it's just a simple 2-input mux. And what we're supposed to do here is with this logic converter, double clicking it and pressing this right here will give us output values here for whatever combination is given from A, B, and C. So in this case, A, B, S. So in the 2-input logic converter, whatever those values are set to, uh, it will give us some certain values here. If we click this button here, this gives us an expression, a Boolean expression that we can use. And if we want it simplified, we could just click this button here and it makes it a lot more simpler, which is nice and really, I guess, efficient when making your own calculations. Okay, so for the fourth question, I was supposed to make a 4-input mux using NAND, NOR, and NOT gates. So what I did instead is, this is my mux 4. I used 3-input NAND gates into a 4-input NAND gate, and this is my 4 mux that I created. And to test it, I have a logic converter here with my mux 4. So press this, we get our resulting expressions, and we could convert that into this equation, and then to simplify it, we get this as our simplified equation. This was also my DMux 8. Uh, I pretty much used the same method that was outlined in the worksheet or the example in the lab procedure. Okay, for the last fifth question, I was supposed to use the 4-input mux that I made and the 8-output demux that I made and make it a sort of telephone switch circuit and make it look like this diagram here. So if we go to my circuit, this is what it looks like. I have my inputs and then I have the light switches, which sort of resembles the telephone light switch thing. And here I got my mux 4, which we can open right here. I showed it earlier. It looks like that. And I also got my demux here, which I also showed earlier, which looks like this. So if we press to run the circuit, we can change the values. And as you can see, only one lights up at a time, and it's different every time. So changing some of these values, we get different results, making these all 1. And as you can see, different light bulbs light up depending on what is on and what is off. And yeah, it's pretty cool. So yeah, this is the end of my demo, and hopefully this will suffice to get enough marks.